All right, welcome back. I hope you're having an awesome time so far. Our next speaker is Senthil Padmanabhan. He's the Vice President Technical Fellow at eBay. Please join me in welcoming him to our virtual stage.
Hello and welcome everyone. Thanks for joining me today for this presentation. My name is Senthil Padmanabhan. I'm a VP Technical Fellow at eBay. I head the user experience engineering for the marketplace, and recently I also started leading the developer productivity engineering. Today's topic is embracing AI in UI. We have a lot of content, so let's get started. One thing that we need to realize these days is this: machine learning is getting embedded in every part of user interaction. Sometimes it's obvious, sometimes it's not. Every search query that you do, anytime you speak to a device, you go online shopping, the recommended items that get shown to you, the price of those items, when you book your vacation, when you press your doorbell, there is some form of machine learning involved. And the main reason for this is there is massive amounts of data, and we all want the best possible results in the most personalized way. So the traditional rules-based programming doesn't get us that. So machine learning is becoming sort of basic and mandatory in all of these areas. However, customer expectations are also changing over time. This is the way things are. As time evolves, customer behaviors change. And that brings us to a very interesting statement. And that statement is, more and more customers expect products to be privacy preserving, always available, and instantly responsive. This is a pretty big statement, and there's a lot of research which proves this statement, but let's break it down. It has three main parts to it. The first thing is the privacy aspect, privacy preserving. We do a lot of things online, especially with the pandemic. It has become a forced function that everything happens online. And a lot of things we do is personal, and we want the personal things to be private. We don't want the whole world to know the things that we are doing, and sometimes we don't even want the organizations that are offering us the product to know about our data. So this has become like a very default and a basic customer expectation. The second thing is the availability aspect, that's being always available. It's not only good for your business, also customers do not like an unstable product. Whenever they see an unstable experience, they think that they are not getting the value out of it. They may leave you and go to another competitor. It is pretty much becoming table stakes at this point that people expect everything to be always available. And the last one is to be responsive. This is all about speed. More and more new crowd that comes to the online platform, they don't like to wait. They want everything quick. They don't like to see a throbber. That is sort of unacceptable to them. Ultimately, it's about consistency here. They want a consistently fast experience. They want a consistently available experience. And they want all of this to be private as much as possible. So how do we achieve that? There are many ways to do that. And one way is to do on-device computing, meaning that doing everything with the devices that is around you. But let me set the context right. This talk is not, I want to tell what this talk is not about. This talk is not about using AI or ML to design or build your user experiences. I know there's a segment of research which says that, oh, machine learning can produce these beautiful designs. This talk is not about that. There is one segment of research which says, hey, with machine learning, we can generate software or write code that will build your user experiences. This talk is not about it. What this talk is about is bringing AI and ML closer to your user's device. Let me explain what this is and why this is only possible when we start embracing AI right from the design and development of your user experience. But first, let's talk about the two main phases of machine learning. Of course, there are many other aspects to it, but primarily there are two phases. The first one is training. I mean, a lot of folks know about this, but let me quickly explain. You take the training is the part where you have this massive amount of data, you take it and you put it into this process called model building. This is where you teach or train the system, right? You teach the system to understand or what you wanted to do. This is where feature extraction comes into place from the data. This is where you adjust your loss functions, you apply weights, you tweak your algorithms, and finally you produce a model. Model is the place where which predicts whatever output you want. And the next phase is inference. So you have a model, what do you do with it? You infer something from it. But this is where a user action also comes into play. So usually what happens, you take a model, you encapsulate it or you wrap it in a service, and then when a user calls that service, it calls the model and it gives you results. The results can be prediction or a classification. Basically, if the user uploaded image is a cat or a dog, and that's what the model says you back. And in most cases, the reason I'm using most is because there are some exceptions to it, but in most cases, training happens offline, inference happens online. By offline, I mean training happens in its own timeline. It happens behind the scenes. Engineers and researchers collect this data and they take their own time to start building this model and train it. And it's not even comes with the user flow. Whereas inference happens real time, as when a user interacts with your system, interacts with your service. And again, I mentioned most, right? Because sometimes training also has to happen in real time, but majority of the cases, training is offline and inference is online. Our focus today is going to be on the online aspects, which is the inference part. Let's also talk about a typical workflow. So a user comes in, they go to that device and they do some action on it, or they want some information out of it. The device makes a call to the cloud. And inside the cloud is where your model is behind a service, and then it does all the calculations, computations, and it gives the results back to the device, and the user sees that. This is how a typical workflow is. An optimized workflow would be to take that model out of the cloud, cut the call to the cloud, and put the model and inferencing inside the device itself. So the device does the inferencing. So in this case, we all carry devices with us, and these devices are getting powerful day by day. I know not all devices are powerful, but at least devices can do many things which was not possible in the past. So why don't we start leveraging that? But when we do this, does it satisfy our customer expectations? Because I highlighted three main things that the customers are expecting. Are we really solving them? Let's see. Privacy. Here, the data doesn't leave your device at all. It all stays within your device. It's in your pocket, or it's in your desktop. So it's by default private. There is nothing which leaves your device. Is it always available? Yes, it is available, because you're not dependent on somebody else maintaining that service up and running in the cloud. Because if your device is on and running, then your service is available for you. And finally, is it responsive? It has to be quick, because the quickest response is the one where you never make a network request. And in this case, you never make a network request. It all happens locally. So it has to be obviously fast. So the question that everybody keeps asking is, okay, so you're saying all the good things about it, then why are we not always doing this? And that's where the rubber hits the road. In reality, it's much more complicated to put it into practice. So let me talk quickly about model quality. So model quality is the place where we talk about how good a model is. Is the model doing what it's supposed to do? And among many other things, the quality or accuracy of the model, the goodness of the model, depends on two critical factors. One is the size of the model, and the other is the computation power. Size meaning how big or small it is. And computation power is how much power does it need in order to get this thing done, how much calculations it has to do. And generally, a higher quality model means it needs a large size, it has to be big, and it's computationally expensive. Since it's big, it has to do a lot of calculations, and a lot of times it has to do these calculations in parallel, and it needs specialized hardware, specialized GPUs and CPUs to do them. So now you get why it's not always possible is because devices, especially mobile devices that we carry around, are constrained on both. Yes, they are getting powerful, but they are still constrained because they don't have the unlimited thing that cloud has, which is pretty much you can do anything with your cloud. You can ramp up your systems, ramp up your memory, you can ramp up your computation power. You just have to pay a big bill, but at least that is something that is under your control. Whereas in the devices, that's not under your control. So does this mean it's end of the story? Then why are we talking about it? The answer is no. There are techniques and use cases that can benefit from on-device inference. We just have to pick the right battle. So how do we make progress from here? The first thing is we need to identify use cases that will benefit from this approach. See, not all use cases need to satisfy these customer expectation. And secondly, it's not possible for us to put all these use cases on the device itself. That is a disaster. So we need to come up and identify these use cases and tune them accordingly. Second is to apply techniques that will enable this approach. Once you identify those key use cases, then you can go and look at the various research areas where this is possible and then start applying them. And this is the change in thought process that I'm talking about. We need to embrace this idea right when designing the user experience itself, rather than it being an afterthought. See, when we build user experience these days, right, UI, we consider a lot of aspects. We consider how interactivity is going to be, how accessibility is going to be taken care, how are you going to represent the whole customer journey, how is your brand being represented, how are we managing clutter in the page. There are a ton of things we do when we build or design user experiences. But we are not thinking in the areas of whether privacy, responsiveness, or availability is considered, or whether machine learning, how much of ML inference is involved in these interactions. This is usually done as an afterthought. Maybe we assume these things are happening, or sometimes we don't even look into these things. But this is the change in thought process that we need to happen, that How does this machine learning inference is going to benefit my user? How am I taking care of my customer expectations? So let's talk about how we can do that, right? Let's first talk about the techniques. We are not going to go in depth about the techniques here. There is a lot of research around this, and many folks are well versed on this. But there are two main things we can think about when you talk about on-device inferencing. One is quantization, and the other is sparsification slash pruning. So quantization is the process where you convert and store your tensors or your model parameters from a high bit width to a low bit width, meaning you are converting your, for example, your 32-bit floating points to an 8-bit integer without sacrificing accuracy. That's the key here. The accuracy should not be satisfied. Basically, you're compromising your precision here, the number precision, and that is okay for a few cases. It will not be a problem. And second thing is the sparsification of pruning, as the name says, it's basically making your model small. And the way this technique works is like by gradually setting a fraction of your model weights to 0 during training. So you do that without impacting the quality of the model, and then you get the size of the model. So both gives you some advantages, right? So you lower the precision, so you get a high performance with low computation. Low computation means you also consume less power. Less power means you also consume less of your battery, because in mobile devices, that's a big deal. So it has all these good side effects. And reducing the size of the model also means you are consuming less storage, you are not overusing your memory bandwidth. So it sort of helps you all. Again, it depends on the use case, it depends on what model you're talking about. Not everything will apply here, but these are the techniques that you can start thinking about. But we're going to talk a lot about use cases today. So, and particularly I want to focus on real world use cases, because theoretically I can give a lot of examples, but if it doesn't have an impact to our customers, then it doesn't make sense. So let's talk about a real world use case here. And that real world use case is going to be eBay image cleanup. So what is eBay image cleanup? So it's a product that we launched last year. It's a computer vision powered tool on mobile platforms for creating images with clean white backgrounds. Um, so when we announced it last year, right, there was a lot of media around it. But basically, the idea here is this: that we wanted our customers, like a normal customers, like consumer sellers, to also have high quality photographs when they list an item. So we evaluated it in two categories. One is the motivation. We needed some motivation on why this use case makes sense. And the first thing was we wanted to have best first impression when listing on eBay. So here I'm talking about consumer sellers, not business sellers, because business sellers run their business on eBay. So they always are there on eBay. But normal sellers, they come once in a while, and a lot of time they come first time, and we wanted to create a very good first impression for them. But it also has a good side effect, because as a result, we have better draft completion rate. Draft completion rate is a metric that we track in eBay, which is like how many percentages of users who started the listing also successfully published it to the marketplace. So the higher, the better, and we want it to improve. Usually, when there is a good first impression, the draft completion rate also improves a lot. And the next one is equal opportunity for both professional and non-professional sellers. This again ties to the core value of eBay. eBay is about economically empowering people, and we want to economically empower everybody, not just people who have access to this high-end tools who can do these nice photographs for them. No, we wanted everybody to have economic opportunities, and this is a good way to do that. And finally, we thought this is a good use case for trying our change in thought process. Like I was talking about this thought process, like why don't we start when we build the user interface itself to think in these angles? And this was a very good use case for us to try it out. I also want to highlight some of the opportunities here. There is also some opportunity cost here, right? So most non-professional sellers use their phones to take pictures, just like people, like normal people. They all have phones. They don't have access to these fancy cameras or all these lighting systems. So we want to provide them the best experience. And secondly, eBay app can be an all-in-one tool for listing creation with built-in photo taking and image processing capabilities. Like a lot of times what happens is people use a different software to make sure that photos and videos are ready, and then they come to a different platform to do the listing. We didn't want to do that. We wanted eBay to be that one app where they can do everything. And finally, this was also an ideal use case to satisfy our customer expectations, the three things I mentioned, because many times customers just want to take a picture. They don't want to decide on listing it yet. They just want to have a quick idea whether this makes sense for listing or not. And that's something sometimes personal for them. They just want to try it and see. And they don't want to send it all the way and upload it and things like that. So we wanted to quickly make sure that they get that experience that they want. And they wanted to quick, and they wanted to be always available because they wanted to clear their garage, and they are some things that they are not comfortable listing yet, but they just want to take a picture and see. So all these things are sort of satisfying these use cases, so we wanted to give it a shot. So how did we do it? So we took a computer CV, a computer vision model, and a C++ library was bundled as a part of our iOS and Android builds. The goal of the inference algorithm is to separate the foreground from the background clutter. So this image is going to help. So you see the sweater here, that's the foreground, and whatever you see behind it is the background. And the goal of it is to basically separate these two both. So what is the output of the algorithm? The algorithm's output is a mask made up of the probability of the foreground for each of the pixel, meaning that this is the mask that's generated. So what the algorithm does is it goes and tells me this for this pixel, it has a higher probability of being the mask rather than the background, being a foreground rather than a background. So for this algorithm, this is the output it produced. And how do you know the output is good or bad? And that's when scoring comes into play. So we have something called the confidence in background removal, and it is measured by a factor that we call separability, which basically estimates how easy it is to separate the foreground from the background. Meaning, if you have high separability, it means that it's a good algorithm, like if the mask is right. So in this case, the mask is right because it gives me the exact area of it, and then you get the picture out of it, and you get a nice high quality photo like you see in like a professional seller listing it. So the feature also consists of two parts to it. One is the auto cleanup, which I mentioned, and also there is manual touch-up because we want to have the best of both worlds, right? You can have a quick way of getting the background removed, but if you're not satisfied with the output, you don't have to go to another tool again. We also provide you this image processing capabilities that the C++ library I mentioned, which allows you to do manual touch-up. This is a good example. See here, there is the background removal that I am talking about right here. The output is good. The phone that you are trying to get, all the white background is removed, all the noisy background is removed, and you have a good white background. But in this case, when you're taking the picture of this microphone, there is some artifact left. There is some sort of noise behind in the background that we still the algorithm didn't remove. But again, we have some image processing capabilities on the device itself, which you are providing with the app, that you can press them and then you can manually tweak them and you can play around and remove them. So you don't have to leave the app and go to another place to do that. I also want to quickly highlight on the app bundling aspect. So basically what happens is like now we have to package all of this library, this light model, everything into the device, which means there is a problem that we're going to face. I'm highlighting Android alone here because Android has this wide spectrum of devices from a low-end device to a high-end device, but iOS is usually on the high end. So it was mostly an Android problem. And what's the problem is the app size. So we have 4 processor architectures to support, and each requires a different build for our native C++ code because we need to build it for ARM, we need to build it for x86 and things like that. And if we included them in the APK file, that is the application file, then these 4 separate builds alone added to 30 to 40 MB to the app size. That is, they increased it by 40 MB. This was unacceptable to us. We didn't want to put this burden on our customers. So fortunately for us, there was a solution, and that was app bundles. So app bundles is a feature that is available in Google Play in the Android OS, which we incorporated it as a part of our build process. Basically, what it does is it allows to distribute the app in a bundle rather than we building it for every platform. So we don't have to pre-build it, and that is actually taken care by Google Play. So the APK generation and signing are deferred to Google Play, which means that they will make sure that they build it and generate the right binary for each of their phones. So based on the architecture, they will generate it and we don't have to worry about it. And that is clearly shown in the numbers here. As you see, the download size, as I told you, is 30 to 40 MB more. With the bundle, it's reduced drastically. Similarly, after you install it, after you download and install it, that size also has been reduced a lot. So this was a win-win for us when we used it, and specifically for the Android platform, it makes a difference. Now let's talk about results. So how did this whole thing go? So we tried this out for a period of time, and during that period, we were monitoring it, and there were 5.5 million sellers who engaged with the tool in that time. And that's a good, impressive number. But more than that, 77% of those drafts were also published to the marketplace. meaning this is more than, so this is the draft completion rate, and this is more than the usual number. And we were pretty happy to see these results, that people love the tool, but also they successfully go and use it to publish it because they were happy with the quality of the image. Because a lot of times, as I told you, right, people start the draft and then they may not like the photograph, they may not have all the information to enter it, and they just sometimes they just lose hope, and they drop it. But here we want to provide them as much as information as possible so that it will successfully able to do them. And it's sort of, with this one of these tools, we are able to achieve that. I'm also going to talk about another use case that it's partially launched to many users, and some users it's getting launched. That's the trading card recognition. So trading cards are a big deal at eBay. Like a lot of people, buyers and sellers, like keep exchanging trading cards, and it's a very big category. In fact, to give some statistics on it, every minute 119 listings, 119 trading cards are listed on eBay. And in fact, for last year, every minute 90 trading cards were sold on eBay. So some pretty interesting stats there. But basically, it's about all these enthusiasts, right? About Pokemon, about sports cards, and things like that. And they had a problem there is, whenever they tried to list an item, they were having this trouble of identifying what trading card does this belong in the product. Like, which is this particular trading card? Is it a Pokemon? What particular product it is? What catalog it is? And they have to every time upload it to the server, and then we have to say it. So we used a combination of on-device processing and server-side processing to solve this problem. So we didn't satisfy all the three customer requirements, but at least we thought through that and tried to solve at least two of them, being available and responsive to some extent. So how it works is this. So we built a lightweight model that's specifically for training cards. And then we use the ML kit that comes with the OS itself, with the two OSs, on iOS and Android. And then what happens is, when the user scans the image, they don't have to upload it, they scan the image, the model inference happens, and it extracts the features of those card, all the like the title and things like that, and just sends those features instead of the image back to the server. The server then quickly responds, since it's just textual communication, it quickly responds with, oh, this will be the right product, this has to be adjusted to, associated to. It either gives them one or a multiple products you can choose from, and the users click on it, then every information is filled for them. They just have to enter the price and few other things, and they should be done. It reduced the listing time into half. So this was a big deal, because originally, if you have to upload the whole picture, it was cumbersome. It has to go, the whole binary has to go, come back, and things. Now we just save the whole thing by the same time by half, and this was again a big win for our customers. Excuse me. There are also other use cases within eBay that I would highlight here. The one is the eBay Motors app. It uses a very lightweight on-device ML model to perform image classification. The eBay Motors app is a different app than our flagship app. It's a standalone app, and this is specifically for motor enthusiasts. And these are the folks who for them, cars are very personal, and they just want to know what sort of a car this is and get some information about it. And they don't want to keep uploading it or publishing it out, and they want it personal, they want it to be quick, and they're always on the go, they want it to be always available. So this is a very good use case for it to try it, and when we have done it. The other thing we are trying, it's not launched yet, is a condition grading that we're trying to do. Like for some categories, conditions are easy. You can easily say whether it's a new or a used item. But for some categories, it's actually tricky, and especially between new and like new, and sometimes sellers get confused. And also, this is a very personal information, because or like they try to make it private until they want to share it, right? They just want to quickly know whether what grading it is, and then only decide whether they want to list it or not. So we are trying on how we can also do this with a lightweight model, and doing it on a machine itself using on-device inferencing. So hopefully we can get this out soon. Excuse me. And finally, I also want to talk about few industry use cases. The first one is cameras and modern phones. So we all carry cameras with us, right? And all those cameras these days have ML inferencing built inside. That is how your night shift works. That is how your portrait snapshot works. The way I look at it is, right, like these cameras are democratizing this whole photography, right? You don't have to have these professional, don't like ordinary people can also take highly technical shots, which was only possible if you have that extreme skill set. It's slowly making it possible for everybody to become like professional photographers. And then the next thing that I want to highlight is grammar suggestions and hate speech detection. The grammar suggestion is something that I personally use, right? When I author something, I want to make sure my grammar is all good. And I don't want to keep uploading, like sending it to the cloud every time. I may not even, because it's something that I'm privately typing and it's within my organization. And I want the suggestions to be quick. I want it to be always available. So this is a very good use case for on-device inferencing. Hate speech reduction is another thing for the society, right? A lot of times people type in something and they don't mean to do that. That's it. Unintentionally, they may end up doing that. So I don't want to keep uploading it and then a response coming back to me saying, flagging as, oh, this seems to be the tone of the speech is not right, and things like that. And even I don't want it to give it to my provider of the product, because then they will tag me, oh, this person is trying to type in a hate speech. So we don't want to do that. So we want to make sure that all of them happens on device, and then we can easily then once it's decided, then you can submit it. The other thing that I'm interested is the low bitrate speech compression. So this is about peer-to-peer communication. Like I want to send my voice over to another person, and a lot of times what happens is, since your devices don't have this compression capabilities, it has to go to an intermediary, and they do the compression and then they send it to the peer. And but but if we have these capabilities in the device itself, if you can compress it very well, then you can just directly send it to the peer. You don't need this intermediary to do it. A good example is the Lyra is a codec that was launched by Google recently, which does very similar things. And finally, I want to talk about interaction with smart devices. These are the devices that are scattered all across your home. You and your family interacted with a lot, and you obviously want it to be personal. Again, not all use cases will fall into these categories, but you want some of your use cases to be personal and private, and you don't want that to be sent to the cloud. And a very good example here that I want to highlight is also the new Nest Hub is going to have a feature called sleep quality monitoring. It's going to say how good or bad your sleep was. And that all happens on your device. See, I don't want anybody to know about the quality of my sleep. And that is all constrained. It's all within your device. That's a good another use case to think about. So I finally want to end this one by putting forth this idea to all you all, right? Like, please start embracing AI and UI. And the way you do it is to evaluate your use cases against these three principles: privacy, availability, and latency. Again, pick your battles here. Not all use cases are needed for this. And secondly, not all use cases will be possible to do it. But at least think through, have this thought process when you design your UI. And finally, incorporate them as a part of your UI design and development process itself. So when you're starting in the beginning, most of the time you do it as an afterthought. I think we should change that mindset and putting this as a part of your development process itself. And that's pretty much what I have. Thank you so much.
Wow, thank you so much for sharing with us. This has been an awesome presentation, and we really appreciate you sharing your insight. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and check out our amazing AI exhibits. Thanks so much, and we'll see you around.